Hello and welcome back to Calculus 1. This is a special lecture aimed to review what we did so far and just put all of the tangent line problems into a single section. So every section in chapter 3 will have homework problems. Find the tangent line, find the tangent line, find the tangent line. So now let's take a look at how to find the infamous tangent line. So first off, tangent line is a linear line y equal mx plus b, which is perpendicular to the curvature at a given point x equals a. So if you have, let's say, a quadratic function like this, you pick a point, the tangent line would go through that point. Now, for this curvature, there is a radius r, which would generate that curvature, and then there is a 90 degrees between the radius r and the tangent line. So tangent line is always perpendicular to the curvature at any given point. Tangent line also shows us the direction and the velocity for a moving vehicle right on the given path. So if you want to, involve a little bit of physics over here, you have the curved path of some kind, and there is a car over here, right on the road. The path is s of t, but the velocity is a v of t, which is the tangent. And this is a vector because it has a direction in which you are going, and it also has the magnitude, which is how fast you are going, which is known as speed. Now, obviously, more on these concepts later on in a course, and more on these concepts, much more on these concepts in Calculus 3 and your physics courses. So a lot of application for the tangent line. Tangent line measures the change. That's another important aspect of this. So I'm going to write that in blood as well. So tangent line measures the change, and that is why it is so important. Now, to find the tangent line, let's go purple procedure. Number 1, get f prime of x. Number 2, m equals f prime computed at a. Number 3, find y using y equal f of x. Sometimes you already have a y. Number 4, use mxy to get b for y equal mx plus b. And then number 5, win, which is, you're right, the tangent line. So this is the procedure. And this procedure is the same for all sections of chapter 3. What changes section to section? Number 1. That's the only thing that changes in each section. In section 3.1, you use the limit. In section 3.3, you use a basic formula. In section 3.4, you use a product rule or quotient rule. In section 3.7, you use chain rule. In section 3.8, you use implicit differentiation. So the only thing that changes is number 1. So I'm going to point the arrow into number 1, and I say depends on the type of the derivative. The rest is the same no matter which section you have. So let's find the tangent line with something that, let's say, has a product rule in it. So say find the tangent line for y equals x minus 3 at x equals to 2. Yes, you can go ahead and multiply this and use the basic derivative. We can also use the product rule, whatever. So to find this derivative, right, we know the procedure. Number 1, find the derivative. Number 2, plug 2 into the derivative to get m. Calculate y. You don't have y given, so calculate y. You have a 2, you plug it in here, you get the y. And then you can calculate b. So let's find the derivative. F prime of x is copy the first, derivative of the second, plus copy the second, derivative of the first. So altogether 2x minus 3. Okay, we have our derivative. That's the step 1. We didn't have to use the product rule. We could have multiplied, but whatever. So now, slope m is the derivative calculated at the point A. In our case, derivative calculated at 2, because the point at which they want the tangent line is x equals to 2. So 2 times 2 minus 3 equals to 1. So slope is 1. To find y, we plug in 2 into original function. So we are looking for f of 2, which is 2 minus 3, which is 2 times negative 1, which is negative 2. So now I have the point 2, negative 2, and I have the slope is equal to 1. Use y equal mx plus b. You can also use y minus y1 and if you want to. So y is negative 2, slope is 1, x is 2, plus b that we are looking for. So negative 2 is equal to 2 plus b, and b is equal to negative 4. So the tangent line is y equals x minus 4. The slope is 1, so. Now let's say you care and you want to check this. The fastest way would be to graph both functions in Desmos and make sure they touch at x equals to 2. So you switch to Desmos. First function is x minus 3. Second function is x minus 4. And if you take a look, you see that the black line is a tangent to the purple line at x equals 2. And it's actually at x equals 2, negative 2, which is what we calculated. This is how you know that you did the problem correctly, because the tangent line has to touch the function. We say kiss the function, right? It has to kiss the function at the point. So they have to meet right there at the single point, and that's it. Now, tangent line cannot cross at any odd angle. It has to shoot right perpendicular to the curvature. Let's find another tangent line. So find the tangent line for f of x equals cosine 3x at x equals yes. You are welcome. Let's go with pi over 12, whatever. Step number 1, get the derivative. Step number 2, get the slope by plugging in the value. Then get the y value, and finally figure out b. Let's take a look at this together. So step 1, right, is derivative. So we know it is a negative 3 sine 3x. The derivative of cosine is negative sine. We copy the argument, and then the chain rule of 3 kicks in there. So, m, which is the slope, is going to be the derivative computed at pi over 12. So that's going to be negative 3 sine of 3 times pi over 12, which is negative 3 sine of pi over 4. Now, sine of pi over 4 is very good, root 2 over 2. And we have our slope as negative 3 root 2 over 2. Great. Now we have to find the y value, which is the function computed at pi over 12. That's the original problem. So cosine of 3 pi over 12, which is cosine of pi over 4, which is, again, root 2 over 2. So we also have a point, pi over 12, root 2 over 2. Y equal mx plus b, and we have y, which is root 2 over 2, is equal to m, which is negative 3 root 2 over 2, times pi over knockoffing 12, plus b. So now 3 will cancel with 12, leave us with a 4 there. So we have root 2 over 2 is equal to negative pi root 2 divided by 8 plus b, and we have that b is equal to root 2 over 2 plus pi root 2 over 8. You can pull out root 2 over 2, but no need, because the tangent line, you can simplify it, so it's really nice. So slope is negative 3 root 2 over 2 x plus root 2 over 2 plus pi root 2 over 8. It's a tangent line. You want decimals? Go ahead, punch it in a calculator, get decimals, if that's what makes you happy. Should we take a look at the exam problem? Or no?
We do that Monday. That'd be nice.
Exam problem on Monday. It's the part of tangent, so it won't be on stream then. Do it now? That's the spirit. X cubed plus y cubed equals to 1. And the point of interest is 0, 1. So we find the derivative first. Now this is implicit. So we have to find the derivative using implicit rule. And that's going to be 3x squared plus 3y squared dy dx equals to 0. Plug in the values. So x is equal to 0, y is equal to 1, m is equal to dy dx, right? So you plug all of these things in. You get 3 times 0 plus 3 times 1 dy dx equal to 0. And what you get is 3m is equal to 0, m equals to 0. Oh, m equals to 0. What kind of line is that, where m is equal to 0? So we have y equal mx plus b. Our y is equal to 1. Our m is equal to 0. Our x is equal to 0 plus b. B is equal to 1. So y, so tangent line is just y equals 1. Horizontal, let me write it in. It's called horizontal tangent.